give the SI unit of energy. SI unit of energy is joules, written as J. Commercial unit of energy, kilowatt hour. SI unit of power is watt, written as W. Difference between kilowatt and kilowatt hour. Kilowatt is a unit of power, not SI unit, just a unit of power. The SI unit of power is watt. Kilowatt hour is commercial unit of energy. The commercial, what we use, we pay our bills and all this, kilowatt hour, which is equal to 1 unit. But the SI unit of power is, of energy, is joule. What determines the rate at which energy is delivered? Rate at which energy is delivered is power. And we know the formulas for power is V into I. Power is also I square R. Power is also V square over R. And power formula, work or energy over time. An electric motor takes 5 amperes, so current is 5 amperes, 220 volts, voltage 220 volts. Determine the power of the motor. The power formula V into I, so V is 220 and I is 5. So power will be 1100 watts. We also have to find the energy consumed in 2 hours. So the time is 2 hours. Now remember, R is not SI unit of time. So time to SI unit is seconds. So into 60 into 60. So time is 7,200 seconds. So energy is power into time. So power is 100 and the time is 7200 seconds. So energy, this will be the energy consumed and that will be in joules. What is the SI unit of electric potential? And that is volt, V. Why nichrome element is commonly used in household appliances? The first point is it has got high resistivity, and because it has got high resistivity, it produces a large amount of energy or heat in this case. The resistance also is high. Then it is second point, it has got a high melting point. So it doesn't melt easily because the temperatures reach very high in the oven or in the geyser, but it does not melt easily because it's got a high melting point. And the last is it does not oxidize easily. At this high temperature, it does not oxidize easily. 10 bulbs are connected in series to a power supply. 10 identical bulbs are connected in parallel to an identical power supply. Which circuit would have the highest voltage across the bulb? So here we have in the first picture, they are connected in parallel, and when they are connected in parallel, say this total voltage is 220 volt. The bulb 1 will also have 220 volt and the bulb 2 will also have 220 volt. In parallel, the voltage remains the same. Now in the second, we have the same voltage 220 volt, but in this case it is spread over 2 bulbs. So this will have 110 volts, this will have 110 volts. Here the V in series is V1 plus V2. V equal to V1 plus V2. So in this case the voltage have you seen for the bulb is not 220, is 110 volts. In this case the bulb voltage for each bulb was 220 volt. So where will they burn brighter? you'll definitely agree they'll burn brighter in parallel, and it'll be dimmer in series. So which circuit would have highest voltage across the bulb? And the answer would be parallel. And which circuit would the bulbs would burn brighter? And that would again be parallel, because the voltage is very high in parallel. In series, the voltage gets spread out. The coils of electric toasters and electric irons are made of alloys rather than pure metals. And the reason is alloys, they're made of alloys because alloys have high resistivity. And the reasons are alloys have high resistivity, they have high melting point, they do not oxidize easily. Metals oxidize easily, but alloys do not oxidize easily. Even alloys have higher melting points than metals. And also they have higher resistivity compared to metals, so they produce more heat as compared to metals. Draw a circuit diagram consisting of a battery with 3 cells of 2 volts each. So here is a battery, 1 cell, 2 cells, 3 cells, 2 volts each, so total will be 6 volts. A 5 ohm resistor, so this is my 5 ohm resistor, a 8 ohm resistor and a 12 ohm resistor, all connected in series, and a plug key. So this is the plug key. And the current will flow from positive to negative, same current, the voltage will be different. Why does the cord of an electric heater not glow while the heating element does? Now here's a toaster. In toaster we have seen that inside there is a red glow when it becomes nice and hot, but the wire that connects it to the socket, this wire, the cord, does not glow. This is the cord and this is the heating element. It is the same current that passes through both, but the heating element glows and the cord does not glow. We'll just draw here. Here we have the cord, the heating element, and this is the cord which is connected to the socket. So this is the cord which is we can see outside. And when the same current is passing through both, but we find that the heating element gets very hot and it gives out heat, but the cord does not get heat. This is the plug to which we connect it. This cord does not get heat because they are made up of 2 different elements. The cord is made up of a metal and the heating element is made of an alloy. This is the difference. So metal have low resistivity, and because they have low resistivity and they produce low heat for the same current, but alloys have high resistivity, and because they have high resistivity they produce high heat, and high heat means they begin to glow. It's the same current passing through both. Here again it's the same current passing through the cord and then going into the toaster, but the heating element will glow, the cord will not glow. In a household we have 5 tube lights of 40 watts. So we have the tube lights, and the tube lights, the power of the tube lights is 40 watt and the number of them is 5. They are used for 5 hours, so the time is 5 hours. Then we have an electric press. So next is an electric press which is 500 watts, time is 4 hours, and they just have 1 electric press. Now calculate the total electrical energy consumed by the tube lights in the press in a month. So formula for energy, power into time. But now remember, the power here is to be in kilowatts. So this was 40 watts, and I'm going to divide by 1000 to make it kilowatts, and the time is 5 hours. This was for one tube light. I have 5 such tube lights, so it will be 40 over 1000 into 5 into 5 tube lights. Here this 5 tube lights, so multiply by 5. So here the tube lights will consume an energy of 1 unit. Let's go up and see for electric press. Again, same formula, energy equal to power into time. Now remember, my power has to be in kilowatts. So 500 watts I divide by 1000 to make it kilowatts. He's given only 500. But I make 500 over 1000 because I need to calculate it in kilowatt. And the time has to be in hours, so it is 4 hours. And it's just one press, so there's no problem. So it's 20. And this is 1000. So the energy consumed here is 2 units. So in one day energy consumed will be by tube lights plus the press. Tube lights consumes 1, press consumes 2. So in one day energy consumed is 3 units. We need to know energy consumed in a month. So for 1 month it will be 30 days into 3 units per day. So 90 units for 1 month or for 30 days.